So, hello everyone. In case there is someone I haven't met, I am Leo, one of the interns at Unidata for this summer. Um, I had the pleasure of spending half of my internship in person, and thus I have met many wonderful people who are also sitting over there right now. The other half I've spent remotely. And yeah, it's been a very good summer. And the title of my project was Extensible NCML for AI ML ready data on the Threads data server. Um, First off, I gotta say big thank you to Tara and Haley. They were my two main mentors and coaches, and basically they helped me out a lot. And of course, Thomas with his overall guidance, tips, tricks, and some funny quirks. Yeah. With that, let me begin. So yeah, like I said, I really enjoyed this summer. I came from Houston to Boulder, and it's been quite a different city. Here is just one photo I've taken from a restaurant, and it's unbelievably pretty to me. So I would say from all the cities I've been in the U.S., Boulder seems to be the prettiest one. Do take mind, I haven't been to like a million cities. I've been to like five, but still, overall, it's been very great, very good pleasure to be there. Also, I had the opportunity to meet some wonderful interns and do some fun activities. Here we are making s'mores at midnight because I said I have never had s'mores. So they all kind of helped me to put a little bit of America in me. So here we are making some s'mores. Here we are, of course, discussing the relevance of atmospheric sciences in a bar, like it usually goes. Then let's see. Oh yeah, I had this pleasure of going to the research aviation facility where we saw this gigantic airplane which collects data, and here I am being overly happy next to the airplane. They even let me, be a pilot, take it out for a spin, stuff like that. So here I am in the cockpit, being all cool and all. Then, yeah. Uh, so what happened during few weekends? We got acquainted with the local people over there, and I even got a gig as a DJ in a local bar. So during day it was PhD research, unit data coding stuff, and during the night it was DJ spin that disc. Finally, yeah, big shout out to the other intern, Anna. We had some really good fun times. Here we are at outing. Um, Although this photo might not do her justice, in person she's like at least 6 feet, or she looks like she's 6 feet, but you know, lenses and everything, it can get cute. Uh, Finally, yeah, I would like to thank you on this mad swagger we got from Unidata. I use it regularly in Houston to have some cold after work beverages while sitting in a pool. All right, so that were the funsies, and now I will say a little bit of what I actually did during this summer. So I spent this summer mostly working with Java code. And why? So the idea of the project was because the geoscientific data sets are only getting larger in volume, but not only geoscientific, every data is getting, as we are collecting more and more data, the AI and machine learning is really being useful to draw some conclusions out of all this data. However, for some of the applications of machine learning, data preprocessing is not only, uh, well, it's pretty much needed for the results to be as good as possible. So what we wanted to do is we asked ourselves, could we develop a framework where data would remain intact while the transformation or the pre-processing of the data could be performed virtually on the server side? And yes, that could be done by creating a what is known as an extensible service provider integrated with the NetCDF markup language or the NCML. And the cool thing about it, since it was made to be extensible, the data providers could create custom transformations which could then be applied to their datasets. So how did we do this? Well, so first we defined a general interface called enhancement provider. With this interface, we then every class or every data transformation, which we call a data enhancement from now on, would implement this abstract interface enhancement provider. And what that means is that all the classes that implement this interface would be loaded by Java at runtime. And that's pretty cool since we didn't have to hard code every class into the actual data set. Finally, we use the NCML to specify exactly which data transformations we want to be applied on the data set, and also the details, how do we want these transformations to actually occur. So let me go a little bit into details. The abstract interface that all these classes should be implementing, called the enhancement provider, this is its final stage. It has two abstract methods. The first one is the applies to, and it's, as you can see, it's a Boolean, which means it only returns true or false. It takes the parameters, the actual enhance or the transformation. It takes the attributes specified by the NCML, and of course, the actual data type of the data set, because we cannot apply any transformation to any types. They need to be match. And finally, the create, which will basically then instantiate the class which will perform the data transformation. So how is this implemented? So before moving forward, I just need to say that before creating the actual service provider, I was tasked with creating one of the data transformations, which was to be used as an example. Not only, so this had actually a couple of benefits because so NetCDF Java directory is huge, and it has already many built-in methods, custom built-in methods written by, I don't know, how many other people. So it was not like super easy and intuitive to just move around all these directories and classes. So by creating my own class and integrating it with the current code, I actually got a much better feeling of how it works and how it is structured. So first, what I did is I created this class called classifier. And as you can see, it implements another interface called enhancement, but that's an old thing. I didn't create this enhancement interface, but it made it part of the enhancement category. Then, somewhere deep down in the code, I created a nested class called provider, which then implemented this enhancement provider interface from the previous slides. And as you can see, it has these two methods that I talked about, the applies to and create. Basically, the applies to will check whether the enhance matches the class's enhancement and whether the attributes actually have the NCML defined attribute, and if the data is correct, in this case, whether the data is numeric. If it's all good, then we will return we'll send this data to the constructor and return a classifier. So here I demonstrate how is this dynamic loading of the interface actually being done. So what we do is we define this variable called enhancement providers, which then, by using the service loader from Java, it loads all the classes which extend or which implement, the enhancement provider interface. Then we have this double nested loop in the variable ds code, where we loop through all the enhancements that exist and match them with the ones that were loaded into the enhancement providers variable. Then we check again, back to those abstract methods. Does the enhancement actually apply to what we wanted it to apply? And if it does, we save it into this set called loaded enhancements. We make this double loop, and that will collect all the enhancements that we wanted, or all the transformations that we wanted, save it into a set, and finally we would just apply the entire set of transformations on the data set. So I spoke a lot about this NCML, but I didn't show it yet. So here is one code snippet of a simple NCML usage. So here, if you take a look, we have this attribute name. It's called classify. What this will do is basically it will activate the class that I talked about called the classification class. And so how do we specify into which classes or which categories? On the right, we have these values. So here you can see we have like two entries which are separated by a what is this dot comma thing. And so basically this specific example will classify all the values between minus infinity and 0 into 0, and all the values between 0 and plus infinity into 1. So a very simple example that just classifies all the negative numbers into 0 and all the positive numbers into 1. And the values that are actually being classified are also given here. But I want to point out that this class for classification can be much more versatile. So here shown is another example, but here you can see that we have many different classes into which the values would be classified, such as minus infinity to 0, 0 to 10, 10 to 100, 100 to plus infinity, and so on. So it can be an arbitrary many classes. And also, so if you take a look at the values, we have some very large negatives, we have some nans, and so on. So the code is robust, and it is written to handle all these, let's say, edge cases. So how will it actually do? What will this classifier actually do? Here we have our NCML example on the bottom part of the slide and some code snippet on the upper part. So first, we will load all the attributes specified by the NCML. In this case, there is only one called classify, but there can be many other, as many as your as many data transformations as one wants. Then we will loop through all these attributes. If in classifier there is an actual classify attribute specified by the NCML, we will do something. So what we will do, we will get the info from the rest of the NCML variable and attribute, get this info, prepare it into, set it up nicely into Java containers, and send it to the constructor. In the constructor, yeah, I will just skip this Java code and go directly into pseudocode. We will loop through all the values of the data set, check where it's a correct type of a variable and not a nan or something else. If it is, we'll send it to another method. And if it's not, we'll just make it minus infinity, or in our case, the lowest integer in Java. Finally, here is the actual small method which classifies every number one by one. Given a number, it will check all the rules or all the classes that exist in a given NCML attribute. And if a number belongs into any of those categories, it will be classified. And if not, like I said, it will be returned, well, ideally like minus infinity or something, but it is Java, so we return like the minimum value of the integer. All right. So that was some explanation of how it works. And here is now an actual example of what it does. So shown here is the raw data of the GFS 1 degree CONUS projection data sets of relative humidity and temperature. So we see it's like relative humidity is from like 15 to 100, and temperature is from like 20 to 90 something. So what we do is we write up this NCML code. we put the attribute name classify, we set up some values, and these values, as you can see in the table below, they mean that the above code will perform the classification of temperature into 0 if it's between 0 and 65, 1 if it's between 65 and 85, and finally 2, everything that's above 85. So after applying this transformation, we see how it looks afterwards. So this was done locally on my PC. However, I have another example where it was done directly on the threads data server, where here we have the relative humidity this time. Again, we do a similar approach with the NCML code. We write the classify as the attribute name. We put some values for the categorization, and boom, there we go. We get the classified data. So here I have only shown examples of the classifier because that was an actual class or transformation that I have written. But like I've mentioned before, any kind of data transformation can now be defined and used. That was like the most important thing. So to conclude, I made, well, with the big help, of course, of Haley and Tara and Thomas, I made the extensible NCML for data processing possible. We developed a solution which now offers a generic server-side data processing without the user actually having to think whether his data would be changed on his hard drive. The TDS administrators can now configure any necessary data transformations, and the users of TDS, or at least the latest snapshot, can now benefit from the pre-established pre-processing routines which can be set up by the administrators. And as an example, I have created a classifier class which was applied to the GFS 1 degree Conus raw data of temperature and relative humidity directly on the TDS just to showcase its capabilities. And that's it. Thank you very much. Thank you to the NSF, Unidata, and all the people who have interacted with me this summer. That's it. Yep.
Thank you, Leo. Do we have questions for Leo? Group.
So Leo, excuse me, does this complement the work that Jessica did last year with the Threads team? So can Jessica's normalizer work fit into your new extensible framework?
Yes, exactly. So normalizer, standardizer, scale offset, any kind of data transformation that we now write in Java can benefit from my service loader, and it can be loaded and applied to the data sets. Yeah, it was actually, I was very grateful for her work because I could see how she did her work, and that helped me out to navigate through the directory a little bit easier. So yeah, it builds upon her work. So it's pretty good. Yeah.
Thanks for sharing, Leo.
It was my pleasure.
Ethan.
Hey, Leo, great work. Looks really cool. Just wondering, can a user that's coming into a TDS request particular parameters or attributes or whatever to be passed in, or is that just hard coded in the NCML?
Yeah, so the user should be able to request what he wants and thus edit the code a little bit and have the data transformation specified to his needs.
Great, thanks.
Thomas, please go ahead.
Yeah, Leo, that was great. I know that you need to do your PhD and other things, but if you could hang out for another year, which we would all love, what would be the next widget you would work on or part of the TDS that you would like to explore?
Oh, that's a good point. You kind of caught me off guard over here. I would have to discuss this probably with Tara, and she would know more on where, in which in which direction to send me. Yeah. I did not think about the other quirks I'd like to fix regarding TDS. But yeah, I think TDS is a great tool, a great piece of software, and I'm grateful you guys developed it and that we can now use it, and that even now I have some work done on the TDS. Boom. Pretty cool. Yeah. Okay. Are there any other questions?
When are you coming back to visit Boulder?
What?
When are you coming back to visit Boulder again?
I don't know. I would say as soon as possible. I really loved Boulder, and I would like to show it off to my friends and to my significant other. And just, although I've spent like a month and a half over there, I would bring other people and say, look, this beautiful place. I've been here. Yeah, I worked here, man. I rode these electric bicycles.
You know, they have this poster conference tomorrow. That seems pretty soon.
Yeah, unfortunately, I cannot be there for this poster presentation in person. But apparently there will be a laptop, which will not even be in the main room. It's supposed to be in a hallway where three of us who will be doing a virtual presentation will be somewhere in the dark. And so if somebody makes a mistake and rounds up over there, he get to listen all these things again with much less fun parts. It would just be like, yeah, serious Java stuff. And,
Well, I'll meet you in the scary hallway tomorrow.
yeah, do come. Yeah. All right.
Any questions out there in the wings? Do a quick teacher pause here. And
just give me a second. So wait, sorry, I didn't hear correct. Was that a question, or did somebody tell me to stop sharing my screen?
no, neither of those.
Well,
I was just waiting to see if there were any more questions coming out. I think we're done. And let's thank Leo again for.
Thank you for thanking me, and thank you for being there. It was really a great time. It's nice meeting all of you. With this, Anna, the floor is yours.